All right, here's your hint for number 10. Now this one's a longer problem, so if you did get stuck somewhere along the way, let's see if we can get you unstuck. So the first part is you're gonna have to do a work kinetic energy theorem to figure out how fast is that clay ball moving just before it strikes the top. Or you could do this with just basic free fall as well. Once it hits it, you can now take this velocity right before impact and use it over here. The platform is initially not moving. Now I do understand that these subscripts are different, and that's because this is a different problem in this one, but they do have this common variable. So we're gonna bring that velocity of that clay ball, the mass of the clay ball. The two are going to collide and stick together, the platform and the clay ball, and then they're gonna be moving at some v prime afterwards. Now this one's kind of interesting because we say it's a conservation of momentum even though gravity's acting on it. The reason we go ahead and say that is that we say that this collision happens so fast that there is no actual time for gravity to have much of an impact on it. Or another way to say it, it's negligible, the force of gravity in this forces between these two objects. Okay, once I have this v prime, I can come over here and do yet again another work kinetic energy problem. So they tell me how far it compresses. Don't forget that that is also a height. So we're going to assume that those change height. So there is gravitational potential energy in this one. At the very end of that work kinetic energy theorem, you have that potential energy from the spring. We're trying to find the spring constant of an individual spring, but in here, this is the equivalent spring constant of all four of those. So once you find KEQ, then you're going to come down here and say, okay, I have four identical springs. So if I add up all four springs, the equivalent spring constant is going to be 4 times each of the individuals, so we can take that 4EQ and divide by 4. Hopefully somewhere in that process, we got you unstuck. There you go.